We good to go? All right, good afternoon, everybody. Thanks for hanging around. I know there's lots of exciting attractions out there, so I'm glad you stayed to see my talk instead of going out to Club Super Sex. So I'm here to talk about process stalking. It is a tool that I've developed for visual reverse code engineering. Let's just dive right into it. So a quick introduction about myself. My name is Pedram Amini, currently employed by iDefense, working in the labs division. I'm a security researcher, developer, and reverse engineer. You may have heard of us probably from our vulnerability contributor program, which has been in its start a program that we launched to buy vulnerabilities from the underground, and maybe from some of our tool releases that we've done recently. Since February of this year, we've had our own division of the website, it's labs.idefense.com. And that'll be the eventual home of this tool, although I'll give a beta out to you guys today, despite the fact that it's not complete yet. So just an overview of what we're going to cover. Start off with some background information, go over the overview and design of the tool set, talk about the features and benefits. I'll give a live demonstration, talk about the in-development portions, and then conclude the talk. Just some quick background information. I'm sure a lot of you are already familiar with this. For the IDO users, call graph. It's just a notion behind, let me take this off. So essentially, disassembled binaries can be visualized as graphs. And the way this is done is that a function is a node and a call is the edge between the functions. And so IDO supports this type of visualization and is useful for reviewing the relationships between functions. That's just a very basic graph I put together in PowerPoint. And so you can see some unnamed functions and what functions that they call, so you can get a general idea of what they may do without actually diving into the binary. However, in real-world scenarios, function call graphs can become completely unmanageable and downright frightening. And this is just, you can't even see the detail under there, but it's been chopped off from left and right, and it's not even as large as a binary can come. Another concept of graphing is control flow graphs. So whereas before you're looking at functions within a binary, you can also visualize the actual function as a graph as well. And the way that's done is the basic blocks are seen as the nodes, and the branches between those basic blocks are the edges. And so I gave an example there. Again, I'm sure at this conference everybody's familiar with it. It shows how that left-hand side static disassembly turns into a graph where the branches become edges and the targets become the new nodes. IDO also supports this type of visualization. It's useful for viewing execution paths. I prefer to view disassemblies in this manner than just a straightforward dead listing. It's just more visually pleasing. Now, there are some shortcomings of the IDA plugin, or rather the IDA WinGraph plugin. It does not do Microsoft chunked code, and so I wrote a plugin called pgraph, which is just an extension on IDA's WinGraph capabilities, and it will actually show you chunk code as well. So the purpose of this tool is to assist in vulnerability development and vulnerability verification and vulnerability discovery. So these are the challenges that I come across in reverse engineering practices that I try to address with this tool. So input tracing, you saw that massive call graph. How do you know which one of those functions and more specifically nodes handle your input? If you can tell which ones those are, you can reduce the process space that you want to analyze to find vulnerabilities. Code coverage. If you have a fuzzer, how can you tell how good your fuzzer is doing? How deep is it into process space? Or how can you track its growth from week to week? How can you get it to be smarter, to get deeper into process space? Complexity. If any of you have ever done a trace in OllDebug, a simple trace can generate thousands and thousands of lines of assembly. How can we reduce the complexity and understanding of that mass machine code? Filtering. Again, if you've ever done a trace in REcon, sometimes the smallest trace will take hours to do because there's all this message handling and GUI nonsense that's going on in the background. How can we filter that out because we're not interested in it? And that leads into trace speed. Is how can we increase the speed of tracing? So an overview of Process Stalker. It requires 3 components: IDA Pro, commercial. There's Python, which is free, and a program that you probably haven't heard of, which is Aureus GDE Community Edition. It is the graphing application that we use for this. I must have spent 12 hours Googling to find a good graphing application, and this was hidden somewhere in the depths of the internet. And it's actually a really good tool. They sell a commercial library for a ridiculous amount of money, but they offer this for free. It's kind of like a demo, and so I really had to finagle my way into using this for my needs, but it works really well. So there's three components to Process Stalker. There's an IDA plugin, there's a standalone tracer, and then there's a Python script, and I'll get into the details of all of these. Everything is open source. This will all be released open source today, and the final version in the future. It's developed in bastardized C, C++, Python with a custom API, and it's built on top of the plugin. IDA plugin is built on top of Function Analyzer, which is a component that I wrote some time ago and also released through our iDefense website. And the tracer is built on top of Dumbug, which I believe was developed by Fino Elite and released at Black Hat last year. There are some related commercial applications. Saber Security, Halvar Flake, has Bin Navi. I've actually never seen it in action, but I know it does similar work. HP Gary has Inspector, and I think SI Secure is either working on an internal tool or something that they'll be selling. I've seen screenshots of it at rootkit.com, but I'm not entirely sure. If anybody has insight into that, I'd be curious. They're all commercial though, they're very expensive, and so I believe this will be the first of its kind to actually give this kind of capabilities free to you. So, I'm going to go into a data flow diagram, just get an overall feel. It's a somewhat complicated tool set overall, but once you start going over it a few times, it'll become familiar and it's really easy to use. So first step is to load your target binary, DLL, whatever into IDA. You take that, you run the IDA plugin, and it exports data to the file system. It exports breakpoint lists, cross-reference files, and a GML, that's the graph type that Aureus takes, for every single function in the target module. So those GML graphs are immediately viewable. They have some benefits over the generic graphs that you can use from IDA or even pgraph because they're interactive. You can actually move nodes around. You can zoom in and out and pan a lot cleaner than you could in IDA. And you can make edits to the graph, whereas you cannot do that in WinGraph. From there, you would take those files and feed them to the actual Process Stalker tracer, which will attach to or load a target process. That, in turn, generates a recording back to the file system, which you could then use to apply onto those graph files to generate a visualization. And we'll get into this later on. Using Python, you can instrument the graphs, combine graphs, you can view cross-references, you can filter things out, and again, view them in GD. And finally, one of my favorite features is that you can make edits directly in GD, directly on the graphs, and then you can export those back to IDA with a script that generates a .idc script that you then run in IDA, and it pulls all those changes back in. So if you're viewing it in the graph, you can make comments, change names, and then port all that back into IDA instead of having to work in both at once. So of the three components, the IDA plugin internals, as I mentioned, is built on top of Function Analyzer. When you run it, an analysis routine is applied to each identified function. For every one of those, a breakpoint entry is generated for every single basic block underneath the functions. And it's a basic file format, just the module name, the function offset, and the node offset. And the reason why we use offsets is because modules can move around in memory. And so that Process Stalker supports it. If you have a module that loads at one base address in one run, and then it moves to another location in another run, you'll be okay. Cross-reference entries are generated for every call as well. And so this is the actual relationship between the functions and nodes. And that's not actually used for the tracing portion, but later on when you want to combine graphs, that file will come into play. And finally, again, a customized .gml graph is generated for each function. File name is just going to be the module and the function address .gml. So the tracer, built on top of Dumbug, it can attach to or load a target process. Every time a DLL load event is hit, it's going to take that module, determine the base address. It'll add it to a linked list and automatically import all available breakpoints. So if you have 12 modules, you don't have to actually specify command line arguments to attach and put breakpoints on those modules, especially since they may not be loaded at startup. You just put them in the same directory as Process Stalker. As soon as the module comes in, it checks to see if there's a breakpoint list. If so, it's going to load it and parse it. Function level breakpoints are put in a self-balanced tree. It's currently unused, but eventually when I add argument enumeration, that's when that's going to come into play. When a breakpoint's hit, if it's an actual startup function, I'll enumerate the arguments, save that. So currently, every time a breakpoint is hit, if you're recording, you write an entry to a file. And again, basic file format, comma delimited. It has the time that the breakpoint happened, the thread ID it happened in, the module base address, and the breakpoint offset. Depending on what your command line options are, it may or may not restore that breakpoint. That's one of the features for speed and filtering that I'll show later on. In case it's not clear, though, there are two notions of breakpoints. It's function level and basic block level, though they show up exactly the same. Finally, there are the process stalker Python scripts. There's an actual API that I have, and it's documented in Epidoc that you'll see when I give this out. It has a couple of components. A GML component can parse these GML files, and it can generate them. There's a bunch of PS parsers for generating the breakpoint list, recordings, etc. And it's really well documented. I think I spent more time on the documentation than I did actually writing some of these tools. And there's already a number of scripts, I think a dozen or so implemented. So you can take a recording and create a list out of it and filter. You can concatenate graphs, you can fold graphs, etc. So now we're going to step into the sexy slides. So these are the features of process stalk. Like after you've done a successful stalk, these are the kind of visualizations you'll be able to generate. So you can immediately see what nodes handle your input. So on the left, we have a hierarchical layout, and on the right, we have a cluster orthogonal layout. And of course, because the screen is small, I've had to take snippets of these. But essentially what you're seeing there is graphs similar to what item might have generated, but they're highlighted. So the red-ish graphs are graphs that were actually hit during your trace. So when you're viewing these graphs, you can see where the actual code path that was traversed. The difference between the layouts are just that functions can get clustered together. So on the left, you're just viewing it without the functions being grouped. And on the right, every one of those squares in the background is an actual function, and those are the basic blocks underneath. It's difficult to see, but if you look on top of, for example, the first node on the left, you'll see a little a break. Above that is actual register data. So the process stalker will do is that every time a node is reached, it will record register data, and it'll try to detect if the register points to a string. If it's ASCII or Unicode, it will actually print the string. Otherwise, it'll just give you an arbitrary number of bytes. I think it's currently set to 32. It's equal to see, but you'll be able to actually put some of these graphs in the bundle that I'll give out, so you'll be able to see it clearly. So automated highlight. Despite the fact that we're going to reduce the input set with filtering, and then we're going to reduce it further by only seeing the nodes that are hidden, I want to also, for a quick audit, be able to determine nodes that may be potentially interesting. And so I have a script that goes through and it will highlight, based on your command line arguments, only look at hit nodes, only look at missed nodes. And it'll say, okay, if it has an inline string copy, highlight it. If it calls any APIs, star string star, or star Alex star, highlight that, because it may be interesting. If we're there, we know that somehow our user input to the target caused it to come to this section. So one of those functions may be interesting as well. It's a pretty rudimentary script. I'd like to make it more intelligent in the future, but it actually does pretty good. And you'll see that in the demo later on. So alternative paths, with process stalker, maybe you're writing a fuzzer and you want to get it deeper into process states. On the left, we see a run where it just went, 1, 2, 3, and then the exit node. But we ran the highlighting script, and we see that there's a potentially interesting node on the right, labeled in purple. So that zoomed in area in the circle, it doesn't have registered data here, but you can have it added, and you can determine to see, okay, what do I need to do to change my input to make it take the alternative path, to get deeper into the process state, to reach that potentially vulnerable node. Speed-wise, process stalker is way faster than single-step tracing. I attempted to graph this, and if I would have, you would have seen no bar for process stalker and the whole screen for Ollie debug and the others. Single-step tracing is much, much slower than this way of just setting breakpoints on basic blocks. To increase speed even more, you can do two modes of operation. There's a breakpoint restore, where every time a breakpoint is hit, it'll restore it, so when it's hit again, it'll log again. Or you can just do one shot, where once a breakpoint is hit, it logs that and it clears it. And that's going to be useful for filtering. And of course, filtering can also further improve performance, because you can filter, maybe if you have a really massive module that has 17,000 functions and 50,000 nodes, maybe you'll only want to see what functions get hit first, do a quick look, see which one of those functions may be interesting, and then reduce the breakpoint list to only look into those. So while we're on the topic of filtering, you can take those generated recordings and use them to join or diff out of breakpoint lists. And so the example that I showed here is in the black area, all those yellow dots are functions. And in the red area, all those yellow dots are also functions. This was a trace of when you take Outlook Express and attach to a news server. These are all the functions that are hit. The ones in the black are the GUI functions, and the ones in the red are non-GUI functions. So if you were to do this trace and do a filter, like you can see, it's a significant reduction of the actual space you want to look at, for the purpose of finding a vulnerability or locating a vulnerability. And this is a vulnerability that we just put out in last Tuesday's Microsoft release, MSO 5030, and it's going to be the demo I'm going to use today. So state mapping, another type of visualization. It's useful for each one of those areas are an actual recording, and the nodes are the functions. And so this is useful for seeing authenticated versus non-authenticated code. Maybe you attach to a SSH server and you fuzz it and you record that, and then afterwards you authenticate with it and fuzz continuously after that and record that as well. And then you want to see the difference, the comparison. Which one of these nodes were authenticated to get into it, which one of them were unauthenticated. A really useful feature of this is that you can use it to monitor your fuzzer. So if you are a manager tasked with tracking one of your employees' performance on a fuzzer, you can do a snapshot of it every week and just graph them all and see how has the fuzzer improved. Has it gotten deeper into process space this week? How much better has it gotten since last week, etc. Recording statistics are something that you kind of just get for free out of doing this. So you can get node hit counts, which nodes were hit the most and the transition times. It's actually not really useful for security purposes, but it was a really easy script to write, so I threw that in there in case anybody found it interesting. It can be used for performance reasons, but no use for me. And so the demonstration. Everybody still hear me? Yeah? So step one is going to be taking the actual plugin, running it, and letting it generate its file. So go and pop into IDA, hit the actual plugin button, launch the plugin, and you have not very many options. You have three options. You can enable instruction colors. That's going to be per node, per instruction coloring. You can disable that if you want your graphs to be smaller, because they're actually rendered with HTML. So the more colors you have, the more tags you're going to have, the larger the graph's going to be. Enabled by default. You can enable or disable comments, again, for graph size, or you can enable or disable self-loops. Self-loops are disabled by default because the orthogonal view will not work. You cannot render an orthogonal graph if you have self-loops in it. So when you run this, I actually won't do it because this binary is pretty big and it'll take like 3 minutes, I think, and I don't want to waste time, but you just give it an output directory. Choose whatever file name you want. It doesn't matter, it's just trying to find the directory. Hit save and it'll start writing that. And so the output is something like this. So you'll see a GML for every single function in the actual module. This is msoe.dll. It's from the grown-up version of Outlook Express pre-patch. And at the end, you'll see the breakpoint list and the cross-reference as well, which follows the same file format that was displayed earlier. So, process stalker, these are the command line options. Can everybody read that from the back or no? Readable? If not, I'll pull up, I have a slide that has it in there. You can attach to a process, you can load a process, you can start in a recorder mode, you can enable one-time breakpoint restoration, and you can enable or disable register recording. All we're going to do is, if you look at the Microsoft advisory and just look at it high-level wise, the vulnerability occurs when Outlook Express first connects to a news server. So we want to do that and filter out uninteresting data. So first we will launch it. So Outlook Express is running. Find the process ID. What is that? 1358? 1588. And we're just going to attach to it. I already have a .dpl in this directory. I've trimmed it down because there's actually like 50,000 breakpoints, which will take again like a couple minutes to set up. But I just want to quickly allow it to go. So it's going to attach to it. It'll detect that MSOE is running. It'll start setting the breakpoints. I think there's 20,000 of them. It's fairly quick. Once this is up and running, there's a number of commands you can execute through the interface. It's interactive. And so I'll show you that in a second. Okay, so these are all breakpoints that are happening right now. So every time, this is all message handling stuff. As breakpoints are getting hit, they're being shown. And you can actually disable the printing of them with verbosity. And the commands that you have here are H for this screen, 0 through 9 will enter a recorder. So you can have 9 different recordings in one session. M gives you a module list. So these are all the loaded modules and the ones that we're stalking, which is only MSOE. And V toggles verbosity, and Q is going to allow you to quit the program. So here, I actually forgot one command line option. So we're going to quit out of that. What we want to do is we're going to enable one time, and we want to filter out all GUI handling stuff. What is it now? 948? So I'm just enabling the -- one time. It's not going to restore breakpoints. Again, attached to it. Sorry, I forgot this earlier. Wait for it to set all the breakpoints. If we wanted to, we could have immediately made it start recording. I'll just, for the sake of the demo, just hit the recorder button when it starts. So you'll see in the output, it actually shows, timestamp, thread ID, R0, we're in recorder 0, I just press 0 to enter it, and then it gives you the breakpoint instantly. So now what I want to do is, I just want to interact with Outlook. So you'll see it going on in the background as I interact with it. I'll just say no here. And the more I play around with the GUI, the less of those messages are going to show up, because we're hitting all the parts of the process that are related to message handling and dealing with this GUI and generating these menus, etc. Things that we're not interested in. We don't care about any of this code. And so you can see it's slowed down significantly. And if I play with it enough, it will eventually stop. And so I can take that recording and then pull it out and then attach again and then actually go through the process of connecting the news group, and I'll see only the code that is actually doing that work. I can filter all that out. So I've already gone ahead and done that. So, imagine we take that recording, we call it whatever, GUI stuff, and we process it. Yeah. That was actually I just copy-pasted it from when I did it, and it had a profanity in it. I apologize. So once you have that, you process the recording with the script, and I'll give these slides so you don't have to write any of this down. And then I'm going to filter out, you see I'm timing it, PS, breakpoint filter, the module name, I'm going to name it no GUI, and I'm making a list out of the processed GUI stuff, and I'm filtering them out. And all these command line options are documented in a manual that I'll give out. And so you'll see in the word count there the difference. Before I did filtering, there's 58,000 breakpoints. Afterwards, it's 50,000. So we've pulled out 8,000 breakpoints that are GUI only. Not to say that we're going to hit all 50,000 of the other ones. There may only be 1,000 or 2,000 after we do that. So then, if we can go, I don't have internet connectivity set up, but if we go and connect to a news group and then record again with that new breakpoint list, we're going to generate another recording that I then made graphs out of, and I will show you now. Those are the commands that generate those graphs. So this is an actual graph. It's in GDE. It's going to be difficult to see because of resolution-wise. So this is the entire space that we have to analyze if we want to find a vulnerability when Outlook Express is connecting to a news server. It's not it's not small, but it's also not huge. It's not the massive amount of huge black blob that you saw earlier in the presentation. And furthermore, it's probably going to exist in one of these reddish nodes. So just to play around with the interface, you can see I can actually grab and move things in here. GD is a really nice tool. I can click and edit stuff in there. If I want to put a comment and then later pull that out with the script, I can. There's this great little Explorer bar, and I have it set up so that every function will have all the nodes underneath it, so you can go through there and follow things around. The different layout modes. You can do orthogonal. You can do cluster orthogonal if you want to pull them together and actually, colorize the functions behind them. There's some other somewhat useless useless layouts such as circular. It looks great though. You can't really do much with that, but essentially hierarchical and cluster orthogonal are going to be what you're using. So this was the first graph. This is just showing the hit graph. Then running the second command, we're going to want to highlight the hit graph. So only show us nodes that were hit and that may be potentially interesting. So again, relay this out. And you'll see, this is pretty fast in laying it out. This is 915 nodes and 1,300 edges. That is not a small graph. And it does a pretty good job of putting it up fast. And so now you can see, we've got this input space, and then we filter it down to the red nodes that we hit. And now even further, the purple nodes are the ones that are, deemed as potentially interesting. And there's only about 20 of them in this graph. And as it so happens, the second purple node in, the logical way that you would have read this is the Microsoft Outlook Express MSO 530 vulnerability. So literally in less than 20 minutes, you could have found this vulnerability using this tool. Or if there wasn't a detailed advisory, you just had to go on what Microsoft told you, and you're in charge of writing an exploit or a signature. Again, in a short while, based off of just a high-level description, you can find the vulnerability. The third graph I want to show, again, same thing. The first one's a hit graph, then hit graph with highlighting, and now it's a hit graph with highlighting plus the registered data. And this is the most useful view that you're going to be using. Okay, so again, it looks the same. If you pull in the actual nodes, where are we? You'll see. Can anybody read that? No? Go in more. How about that? So you'll see, disassembly, it's purple, it was hit, and it was marked as interesting. The reason for that is the inline string copy that you see over here. Where's my mouse? My mouse is down. There we go. The inline string copy over here, and then this is the register data. It gives you the value of each register when this node was hit, and then I detected that a single dereference of EDI, it's a stack pointer, that's the data that's in it, and what is that? EDX and ESI point to the heap, and that's the data that they contain. If you scroll up a little bit, or if you sniffed while you were doing this, you'll see that this is actual text data that comes right off the wire. And so, right then and there, you can see, okay, well, rec move SD, it's moving into D, which is a stack-based buffer, and it's coming from S, which is right off the heap, probably off the network, and it's my data. Like that string is from the actual connection, and therein lies the vulnerability. Literally within 30 minutes, you could have put this thing together. So GD, great tool, and overall, I had one of our interns put this together. For those of you who prefer the hard copy method, GDE can also print blanketed graphs. This one will fail. No, it's good to go. You can come and look at it later. You'll see that is the actual GDE generated graph. Thank you. So, in development, things I'm still working on is argument dereferencing. We have registers in there. It'd be nice to, at the start of every function to see what the arguments are. Again, I'll apply smart ASCII Unicode string detection. I'd like to do smarter highlighting. There's definitely some false positives in the highlighting. It's still really good. It's very fruitful. Using this tool, I was auditing a popular IMAP server. I wanted to demo that today, but the patch isn't available yet. And so, again, within less than 30 minutes, I was able to find a remote root pre-auth. And so it's very, very powerful tool, I think. Other ideas I've had, which will not be developed anytime soon, are arbitrary data structure visualization. So when you're dereferencing a register, if the actual structure pointers are at the top of it, you can detect that. And then it'd be nice to be able to visualize. If it's a linked list or a double linked list, to actually draw that, pull that into the graph. Data flow visualization, where you actually can watch data move around, is also something I've been tinkering around with in my head. You can do it with memory breakpoints, but ideally you would do it with emulation, which goes into potential design changes. Perhaps I will switch from a debugger application to emulation. So Box has a really nice instrumentation interface. It's slow, but it's going to give me the ability to do data flow visualization. I'd also potentially like to remove the dependency on IDA. When I first set out to create this, I wanted it to be completely free. When I contacted, and IDA had a 4.3 freeware available. However, they are not going to be releasing an SDK for it, so there's that one commercial component. And it's really a small component. I just happened to use it because when I was first developing it, I had function analyzer and it was really easy to do. But I would potentially like to remove the dependency on IDA. One thing I didn't show you, which we might as well, is the actual exploit work. This is actually going to be hard to see. Does that say 192.168.166.1? So the only bad part about this vulnerability is that you actually have to say yes when it connects to the new server. I guess what we're going to have to do is just run it in here and then switch to the other screen. It's not going to be any other way, so we'll just stop. All right, we can do this. So on the left is the exploit server. It's just sitting and listening. On the right is it's going to be a reverse connect back shell is where it's going to retrieve it. And so we'll just say yes. So you'll see on the exploit server it received a connection and it started sending things to it. And on the right, sure enough, we have our command prompt on that vulnerable system. So in development science, things I'm still working on is arguments and referencing. We kind of registered there, and nice, so it started working functions to see what again, I'll apply smart ASCII unit code to string protection. I'd like to do smarter highlighting. There's definitely some challenges in the highlighting. It's still really good. It's very useful. Using this tool is especially popular time actually. A lot of them will have their ladder hashes as well as putting together. So I think in less than 30 minutes for any immediate questions pre-op. So it's very, very powerful tool. Other ideas I've had, which will not be developed next time, arbitrary data structure visualization. So here dereferencing the register, if the actual structure pointers are at the top of it, you can detect that. And then it'd be nice to visualize linked list, double linked list, and actually draw that, put that into a graph. Data flow visualization, actually can watch data move around. It's also something I can tinker around with my head. To do with memory breakpoints, ideally you would do that. You're going to have a lot of false positives. So once design changes, that you may want to really take, for example, perhaps I would switch from a debugger application to emulation. If you bought the old instrumentation interface, the old DLL, this is going to give me the ability to a lot of changes. Or maybe you can also potentially move the dependency on where I first set out to create this, I wanted it to be, in theory, it's free right now. When I got to the end, might have had a 4.3 freeware available. However, are not going to be released an SDK for it, so there's that one commercial component. And it's really a small component. I just happened to use it because when I was first developing it, I had function analyzer and it was really easy to do. But I, would potentially like to remove the dependency on measurement. In terms of self-monitoring. Yeah, no, I've never thought about it before, actually. I'd have to look into it. I mean, as long as the instructional alignment didn't change, that would be an issue. Sure. But if it's going to modify itself, it may overwrite the breakpoint, it may cause a crash, it's going to change that too. So it's actually really a question. Damn you for asking. Any other questions? Before I sign off then, my present to you guys, aside from this, which you can pull down, it's on, nobody's mentioning it, it's a conference, REcon.cx, pull down people's slides, and only that, there's a whole bunch of saved downstairs videos you got my names. But one thing that I've been working on for some time now is wanting to create a community, a website geared towards reverse engineers, similar to REcon.com. And so I finally finished it last night, or at least in its initial stages. So it will go live on Monday. So you guys open our server, log in and password to beta/beta. Boot it up, any bugs you can find, send it over to me so I can get it fixed. On Monday this will open up. I hope it catches on. We'll see. Post it, plug in, download it. One concept that I can really interesting is, I don't know if you guys have seen IDSync, which is a tool that was used in the lab where it connected together. Essentially, multiple ID users can whatever 3 hours. Multiple ID users can in real time work with one another on comments and name changes that make database. So towards function code analysis is really useful. So I put together all right, so just any distribution first, thank a couple of these guys. Create all those IDSyncs out of this lab in the field that manage data types and cogs. And especially my term of slave away analyze the same latter half of this last Thursday. Next time we see any questions, just throw it up in there. And a bunch of volunteers jump aboard and just sitting there watching comments and name changes playing. I did database speed. No, this has nothing to do with it. Actually, the question was, is this process software using these sites? No, it doesn't at all. It uses this Oreo GDE. Oh, there it is. Which is really the... I think you asked about this yesterday. A colleague of mine named Andrew Pence is releasing it today. It's really downloaded now. Yeah, one thing you can do is when you're into things, so you can take, you're going to have a lot of false positives. So one interesting thing that you may want to do is sync server. So it's a really interesting tool, and I look forward to any comments that anybody may have. And I think that's it. Wraps it up.